What is encryption? Encryption is the process of converting plain text or data into a coded message that can only be read by authorized parties. The purpose of encryption is to protect the confidentiality, integrity, and authenticity of data. Encryption algorithms use mathematical functions to scramble the data in such a way that it becomes unreadable without a key or password. Introduction and history of encryption. In today's digital age, the security of our personal information is more important than ever before. Encryption is a method of encoding data to protect it from unauthorized access, and it has been used for centuries to keep sensitive information safe. In this video, we will explore the history of encryption, how it works, and its importance in modern society. Types of encryption algorithms. There are two main types of encryption algorithms: symmetric and asymmetric. Symmetric encryption uses a single key to encrypt and decrypt data. This means that both the sender and receiver must have the same key. Asymmetric encryption, on the other hand, uses two keys, a public key and a private key. The public key is used to encrypt data, while the private key is used to decrypt it. Popular encryption algorithms. There are several popular encryption algorithms used today, including Advanced Encryption Standard, AES, Data Encryption Standard, DES, and Rivest-Shamir-Edelman, RSA. AES is a symmetric encryption algorithm that uses a 128-bit block size and can use keys of 128, 192, or 256 bits. DES is an older symmetric encryption algorithm that uses a 56-bit key. RSA is an asymmetric encryption algorithm that uses keys of 1024, 2048, or 4096 bits. How to encrypt data. Encrypting data is a simple process that can be done using various software tools. One popular tool is VeraCrypt, which is a free, open-source encryption software. To encrypt data using VeraCrypt, you need to create a container file and then mount it as a virtual drive. You can then copy your sensitive data into the virtual drive, and it will be automatically encrypted. Best practices for encryption. While encryption is an effective way to secure data, it is not foolproof. There are several best practices that you should follow to ensure maximum security. First, use strong passwords or keys that are difficult to guess. Second, keep your keys or passwords safe and secure. Third, use reputable encryption software that is regularly updated. Fourth, encrypt all sensitive data, including emails, files, and messages. Challenges of encryption. While encryption is an effective way to secure data, it also poses some challenges. One challenge is the complexity of encryption algorithms, which can make them difficult to implement and manage. Another challenge is the performance impact of encryption, which can slow down systems and applications. Finally, there is the risk of losing keys or passwords, which can result in permanent data loss. Encryption and compliance. Encryption is also important for compliance with various regulations and standards. For example, the Health Insurance Portability and Accountability Act, HIPAA, requires healthcare organizations to encrypt patient data to protect their privacy. The Payment Card Industry Data Security Standard, PCI DSS, requires merchants to encrypt credit card data to prevent fraud. The origins of encryption. The origins of encryption can be traced back to ancient civilizations such as Egypt and Greece. The Greeks used a device called a cytale, which was a rod with a strip of parchment wrapped around it. The message was written on the parchment, and when unwrapped, it was unreadable without the correct rod. This method of encryption was simple but effective. In the Middle Ages, encryption became more sophisticated with the use of ciphers. Ciphers are algorithms that replace letters or words with other symbols or letters. One of the most famous ciphers is the Caesar cipher, named after Julius Caesar, who used it to communicate with his generals. The Caesar cipher replaces each letter in the message with a letter a certain number of positions down the alphabet. The Enigma machine. During World War II, encryption became even more important with the development of the Enigma machine. This machine was used by the Germans to encrypt their messages and was considered unbreakable. However, the Allies were able to crack the code with the help of mathematicians and code breakers such as Alan Turing. The Enigma machine used a series of rotors to encrypt messages. Each rotor had 26 positions, and as each letter was typed, the rotors would rotate, creating a different encryption for each letter. The Allies were able to crack the code by using a machine called the bombe, which could test millions of possible settings in a matter of hours. Modern encryption. Today, encryption is used in a variety of ways, from securing online transactions to protecting sensitive government information. Modern encryption uses complex algorithms and keys to encode data. The most common type of encryption used today is called symmetric key encryption. This method uses the same key to both encrypt and decrypt the data. Asymmetric key encryption is another type of encryption that is commonly used. This method uses two keys, a public key and a private key. The public key is used to encrypt the data, while the private key is used to decrypt it. This method is often used for secure online transactions such as online banking. The importance of encryption. Encryption is important for a number of reasons. Firstly, it protects our personal information from hackers and cybercriminals. With the rise of online shopping and banking, our personal information is more vulnerable than ever before. Encryption helps to keep our information safe and secure. Encryption is also important for businesses and governments. Companies store sensitive information such as financial records and customer data, which could be disastrous if it fell into the wrong hands. Governments also store sensitive information such as military secrets and intelligence, which could have serious consequences if it was accessed by unauthorized individuals. The future of encryption. As technology continues to advance, so too does encryption. Quantum encryption is a new type of encryption that uses the principles of quantum mechanics to encode data. This method is considered unbreakable, even by the most advanced computers. Another area of development is homomorphic encryption, which allows data to be processed while still encrypted. This method could have significant implications for cloud computing, as it would allow data to be processed without the need for decryption. Conclusion. In conclusion, encryption has a long and fascinating history, from the simple cytale to the complex algorithms used today. Encryption plays a vital role in keeping our personal information safe and secure, and it is important for businesses and governments to use encryption to protect their sensitive information. As technology continues to advance, so too does encryption, and we can expect to see even more innovative methods in the future.